Yes. So we are subtracting 22,746 minus of minus 8,177. It will be 30,293. You just add del power 4 also. So just subtract 30,293 minus of minus 10,435. It will be 41,358. Right. So you can see you can stop when you have only one value. Right. So you just have to go del power 5 if I have two values here. So you can stop when we have only one value. And this is del y naught, right? This is del y naught, and this is del square y naught. That is in del square, the first term, that is del square y naught, and this is del cube y naught, and this is del power 4 y naught. Right? So in del, first term is del y naught. Second term will be del y1. So we don't care about this, because in formula we are only need. In formula we need y naught, del y naught, del square y naught, del cube y naught, and del power 4 y naught. So you can see in formula we have found y naught, del y naught, del cube y naught, del y naught. Yes, we can also have del power. We can also add del power 4 also, because del power 4 also we are getting value. So we just add plus n into n minus 1, n minus 2, n minus 3 divided by 4 factorial into del power 4 y naught. So we have found y naught, del y naught, del square, del cube, del power 4. The only thing that we need to find is n, right? So if we find n, then the problem will be over if we substitute all value here. Now for finding n, you should make use of this here. You should make use of this. That is x is equal to x naught plus nh to find n. So after this, to find n, so you just make use of x is equal to x naught plus nh. So from this formula you can find n. So that is x. So x is the unknown that we need to find. So what we need to find? We need to estimate the population at 1905. So our x will be 1905. X naught is the first value. This is our x naught, right? This is x naught. This is x naught, x1, x2, x3, x4. X naught is the first value in x. So it is 1891 plus n into h is the interval width. H is the interval width. So what is the interval width here? It is 10, right? It is 10. So it is 10. So you can find n from here. So this implies 1905 minus 1891 is equal to 10n. So 1905 minus 1891, it will be 14, right? 14 is equal to 10n. So this implies n is equal to 1.4, right? So n is equal to 1.4. So that's it. So whenever you're given the question, you just form the difference table. So difference table is just you need to subtract this value and write it in the middle term, and then you find n. Now we can substitute in formula. So what is formula? So y of x is equal to x naught plus nh is equal to y naught plus n by 1 factorial del y naught plus n into n minus 1, n minus 2 by 2 factorial, n into n minus 1 by 2 factorial del square y naught plus n into n minus 1, n minus 2 by 3 factorial del cube y naught plus n into n minus 1, n minus 2, n minus 3 by 4 factorial del power 4 y naught. We can stop formula here because we don't have del power 5 y naught. So we can stop up to del power 4 y naught. Now just substitute all the values. So what is y naught? So y naught is the first value in y. So you can see this y naught, del square y naught, del cube y naught, del power 4 y naught. So it is 98,752. So 98,752 plus, so n is 1.4 by 1 factorial. So 1 factorial is 1. Del y naught. So del y naught already found. So del y naught is 35,533. 35,533 plus n into n minus 1. So 1.4 into 1.4 minus 1 by 2 del square y naught. Del square y naught is 2258 plus n into n minus 1. So n into n minus 1, n minus 1, n minus 2 divided by 3 factorial is 6 into del cube y naught. So del cube y naught is minus 10,435. So minus 10,435 plus n into n minus 1, n minus 2, n minus 3 divided by 4 factorial is 24 into del power 4 y naught. So del power 4 y naught is 41,358. 41,358. So that's it. So just make use of calculator, just find all the values and then sum up. So you will have, I don't want to write all the values, right? It's very elementary. So you just multiply 35,533 with 1.4 and then you just find this value and then multiply 2,258 and then again just find 1.4 into 1.4 minus 1 into 1.4 minus 2. You can do this. You do this separately. You do this separately in calculator. In single stroke you can do, right? Again you do this separately. And then you will have this value plus this value plus this value plus this value plus this value. So you will have the answer to be 1,48,304. That's it. So this is Newton forward interpolation formula, right? So therefore this will be 1,48,304. We are interpolating what will be the value in between the interval, and you can see this is lies in first half. So you can use Newton forward interpolation formula, right? So we will do one more problem. So when you are given the problem with Newton forward, you just start with difference table. After difference table, you just find n using x is equal to x naught plus nh. X is the unknown that we need to find. X naught is the first value in x. H is the interval width. So this h is interval width, and this x is the unknown we need to find. X naught is the first value of x. This is 1891 is the first value. N is we need to find. So we'll do one more problem in Newton forward. So problem 2. The value of y is equal to f of x for x is equal to 0, 1, 2, 3, 4, 5, 6 are given. So this is x, this is y. So 0, 1, 2, 3, 4, 5, 6. This 2, 4, 10, 16, 20, 24, 38. So find y of 3.2, right? We need to find 3.2 value. We need to find 3.2 value using forward interpolation formula. And if the value lies in middle, you can use either forward or backward, right? You can use any formula. You may ask the 3.2 lies in second part, why don't you use Newton backward? You can use Newton forward also, you will get the same answer. The only thing is you will get more accurate answer when you use backward when it lies in the second half of the table. Here 3.2 lies in middle part, so you can use either you can use forward or backward. So using forward interpolation formula. Solution. So first we will form a difference table. So it will be x, y, del square y, del cube y, del power 4 y. So x is 0, 1, 2, 3, 4 and then 5 and then 6. So y is 2, 4, 10, 16 2, 4, 10, 16, 20, 24, 38. Now just subtract 4 minus 2, it is 2. 10 minus 4 is 6. 16 minus 10 is 6 again. 20 minus 6 is 16 is 4. 24 minus 20 again 4. 38 minus 24, so it is 14. 6 minus 2 is 4. 6 minus 6 is 0. 4 minus 6 is minus 2. 4 minus 4 is 0. 14 minus 4 is 10, right? You just write this value in middle. And again 0 minus 4 is minus 4. Minus 2 minus 0 is minus 2. 0 minus of minus 2. So 0 minus of minus 2 will be it will be 0 minus of minus 2, it will be plus 2. 10 minus 0 is 10. So minus 2 minus of minus 4, it is minus 2 plus 4. So minus 2 plus 4 is 2. 2 minus of minus 2 will be 4. 10 minus 2 is 8. And del power 5y. So 4 minus 2 is 2. 8 minus 4 is 4. And del power 6y will be 4 minus 2 is 2. This is our difference table. This is y naught. This is del y naught. This is del square y naught. This is del cube y naught. And this is del power 4 y naught. This is del power 5 y naught. And this is del power 6 y naught, right? So again you can just apply the formula here. So we will find n. So for finding n, we will use x is equal to x naught plus nh. So x is the unknown we need to find. So we need to find the value at 3.2. X naught is 0. So 0 plus n into h is 1. You can see the interval with this 1. So therefore this implies n is equal to 3.2. So with this n and with this x naught, so y naught, del y naught, del square y naught, you just substitute in formula, you will get the required answer, right? The formula will be extended to 5 factorial plus 6 factorial, because we have up to del power 6. So the next it will be, next term will be n into n minus 1, n minus 2, n minus 3, n minus 4 divided by 5 factorial del power 5 y naught plus n into n minus 1, n minus 2, n minus 3, n minus 4, n minus 5 divided by 6 factorial into del power 6 y naught. So when you use that formula, you will get the answer, and it will be approximately 17.28. So answer is 17.28. So this is Newton forward integration formula, right? So again it's very elementary, and we will do one more problem. Problem 3. From the following table, find the number of students who obtained marks less than 45. The table is marks, number of students. So it is 30 to 40 and 40 to 50, 50 to 60, 60 to 70, 70 to 80, 31, 42, 51, 35, 31. So here you can see this is x and this is y, and here it is not single point, right? So in the previous problem we have this is a single point, this is a single point, this is a single point, this is a single point. But here you can see they have given the interval here, right? They have given the marks with, it is the number of students who scored from 30 to 40 is 31 students, and number of students who scored marks between 40 to 50 is 42 students, and there are 51 students who scored marks between 50 to 60 they are given, right? So first what we need to do is we need to convert into cumulative frequency, right? Suppose in question if they given the interval, so first we need to convert this into cumulative, right? We need to convert into cumulative frequency. So our new x, new y, new x, new y. So less than 40, less than 40, I use LT, so less than 40, less than 50, less than 60, you just take this as a endpoint, less than 40, less than 50, less than 60, less than 70, less than 80. Now less than 40 is 31 students, less than 50 will be 31 plus 42, 31 plus 42 will be 73, and less than 60 will be 31 plus 42 plus 51. So 31 plus 42 plus 51, it will be 124. Less than 70, it will be 31 plus 42 plus 51 plus 35, it is 159. And less than 80 will be 31 plus 42 plus 51 plus 65 plus 31, it is 190, right? Now we need to find marks less than 45, that is we need to score less than 40, less than 50. So less than 45 lies between here, so less than 45. Now we can use Newton forward interpolation formula, right? So we need to find less than 45 here. Yes. Now again first we will form a difference table. Now you just take x as 40, x as 50, x as 60, 70, 80, right? Because everything is less than. Yes. Now we will use difference table. Now we'll form difference table. So x, y. So whenever you are given the you are given a class interval, you need to find cumulative frequency, and then you can carry on by previous method. So x, y, del square y, del cube y, del power 4 y. So x is, so you just write less than common, less than 40, 50, 60, 70, 80. This less than is for every x. So less than 40, 50, 60, 70, 80, and it is less than 40 is 31, less than 50 is 73, it is 124, it is 159, and it is 190. So del y will be 73 minus 31, so it is 42. 124 minus 73, it is 51. 159 minus 124, it is 35, and this is 31. 190 minus 159. 51 minus 42 is 9. 35 minus 51 is minus 16. 31 minus 35 is minus 4. Minus 16 minus 9 is minus 25. Minus 4 minus half minus 16 will be plus 12, and this will be 12 minus half minus 25 will be 37. So therefore this is our x naught, this is y naught, and this is del y naught, and this is del square y naught, and this is del cube y naught, and this is del power 4 y naught. Now we need to find n, right? After that we need to find, so for that we will use x is equal to x naught plus n into h. So what is x? Unknown, we need to find, it is 45, right? Everything is less than, so you just take x to be equal to 45. So 45 is equal to x naught, so our starting value is 40. 40 plus n into, and what is the interval width? It is 10 into 10. So this implies 45 minus 40, so 5 is equal to 10n. This implies n is equal to 1 by 2, so 1 by 2 is 0.5. So n is 45 minus 40 is 5, so n is 0.5. Now we will substitute everything in formula. So y of x is equal to x naught plus nh is equal to y naught plus n by 1 factorial del y naught plus n into n minus 1 by 2 factorial del square y naught plus n into n minus 1 n minus 2 divided by 3 factorial del cube y naught plus n into n minus 1 n minus 2 n minus 3 divided by 4 factorial del power 4 y naught. We can stop here because it stops at del power 4 y naught. This is a table. These are the headings. Just make some decorations. So just substitute everything here. So what is y naught? So y naught is the first value of y. It is 31 plus n is 1 by 2, so which is 0.5 by 1 into del y naught. So del y naught is 42. Del square y naught is 9. So 42 plus n into n minus 1. So 0.5 into 0.5 minus 1 by 2 del square y naught, which is 9 plus n into n minus 1 n minus 1 n minus 2 divided by 6. 3 factorial is 6 and del cube y naught. So it is minus 25, I think. Yes, minus 25 plus n into n minus 1 n minus 2 n minus 3 divided by 4 factorial is 24. Del power 4 y naught is 37. So again you just make use of calculator, just find all the value and then sum up. You will have 47.867 or 868, which is approximately 48, right? Approximately 48. So there will be 48 students who scored less than 45, right? That is 40 students have scored 31. Number of students who scored marks less than 40 is 31 students. And number of students who scored marks less than 45 will be 48 students who scored marks less than 48. So we can interpolate. Interpolate means we can able to judge the unknown value, right? So that's it. This is forward interpolation formula. So I'll want to do one more problem. So weight number of students. So they are given the number of students whose weight, right? So 0 to 40. So number of students whose weight is between 0 to 40 is 250, and number of students whose weight from 40 to 60 is 120, and 60 to 80 is 100, and 80 to 100 is 70, and 100 to 120 is 50, right? Find number of students whose weight is in between 60 and 70, right? So again one slight tricky problem. If they are given the question like find the number of students whose weight is less than 60, we can use the previous problem method. If they are given find the number of students whose weight is less than 70 means again we can go by previous problem. But here they asked us to find the number of students whose weight is between 60 to 70, right? So for that we need to find the number of students whose weight is in between 60 and 70 is equal to number of students whose weight is 70 minus number of students whose weight is 60, right? So in order to find number of students whose weight is in between 60 and 70, so it will be number of students whose weight is in between 60 and 70 is equal to number of students whose weight is less than 70 minus number of students whose weight whose weight is less than 60. That's it, right? So in order to find the in between 60 and 70, you need to find number of students whose weight is less than 70 and number of students whose weight is less than 60. So you just find y of 70 minus y of 60, where y of x is the number of students whose weight is less than 70, whose less than x. So again we need to find y of 70 as well as y of 60. To find y of 70 and y of 60, we should go by previous problem. So first we will find I'll only do first part. So to find y of, first we will find y of 70. So y of 70 first we will find, and then we will find y of 60. So before that, what we need to do is we need to find the cumulative, right? Cumulative. So it is x, and this is y, and this is del y, and this is del square y, del cube y, del power 4 y, and here it is given that weight is given, right? So weight less than 40, less than 60, less than 80, less than 100, less than 70. So it will be less than 40. So there are 250 students whose weight is less than 40, and less than 60 will be 250 plus 120. So it will be 370, and weight less than 80 will be 250 plus 120 plus 100. So it will be 80 will be 250 plus 120 plus 100. So it will be 470, and again less than 100 will be 250 plus 120 plus 100 plus 70, less than 100, less than 120. So it will be 540, and it will be 590. Now again similar by previous problem, so just fill the difference table. So it will be 120, 100, 70, 50, and this is minus 20, minus 30, minus 20, minus 10, minus 10, and this is 20. This is y naught, and this is del y naught, and this is del square y naught, this is del cube y naught, and this is del power 4 y naught, and this is x naught. Now you need to find n. So for finding n, x is equal to x naught plus nh. So for here our x is 70, right, and for here our x is 60. So you don't need two different tables for finding y of 70 and y of 60.
The last term 10, right? Hello.
Yes.
In delta cube y, sir, one is minus 10, other one is 10, right?
Yes. Okay, sorry. Plus 10. So minus 20 plus 10. So x is equal to x naught plus nh. So here x will be 70, and for here x will be 60. So first we will find y of 70. For this our x will be 70 is equal to x naught is 40 plus n into, and you can see our h is 20 here, 40, 60, 80. So it will be 20, and this is equal to 30 minus 20n. This implies n is equal to 3 by 2, right? 30 by 20, 0 will get cancelled. So 3 by 2 will be 1. So 3 by 2. So 3 by 2 will be 1.5. Right. So with this x naught, y naught, del y naught, and with this n, you find y of 70. Right. That will be x naught, y naught plus n by 1 factorial del y naught plus n into n minus 1 by 2 factorial del square y naught. So just make use of this formula. You just substitute n to be equal to 1.5, and you just substitute y naught, del y naught, del square in the formula. So you will have the number of students whose weight is less than 70. So you will have this to be equal to 423.59. So which is approximately 424, right? So when you are given to find number of students, you always correct that to whole number, right? Because the number of students will be whole number, right? So you always convert decimal to whole number. So it will be 424. Now you need to find y of 60, that is the number of students whose weight is less than 60. So again, for here the difference table is same, but our n will be different. To find n here, x is equal to x naught plus nh. So here x is 60 here. So here x is 70, here x is 60. X naught is same plus n into 20. This implies 20 is equal to 20n. This implies n is equal to 1 year, right? So here n is 1.5, here n is 1. So again you just substitute all this in the formula with n is equal to 1, and del y naught, del square naught all are same as in the previous as in this difference table. So you will get this answer as y of 60 will be yes, and actually you don't need to find y of 60 because less than 60 we already know the data, right? Less than 60 we already know the data. Suppose in exam, suppose in question, if they are given us to find the number of students whose weight is in between 50 and 70, means you need to estimate 50 also. But here they are given us to find number of students in between 70 and 60. So y of 70 we don't know the data, but we know y of 60 already. So for y of 60 we can straight away use number of students less than 60 is 370. So y of 70 minus 370, right? So you can actually don't need to find y of 60 because y of 60 we already know, right? Y of 70 we don't know. Suppose in exam if they ask us to find number of students whose weight is in between 70 and 50, you need to find y of 50 because we don't know y of 50. But here they are given number of students in between 70 and 60. So y of 70 we don't know, which we have found. Y of 60 we already know, it is 370. So y of 70 which we have found. So which we have found is as actually we don't need to find y of 60, right? So after this you just find y of 70, it is 424. So it will be 424 minus 370. So it will be 54. So there are 54 students whose weight is in between 60 and 70. If both are unknown, then you can find y of 60 by using Newton forward interpolation formula. But y of 60 we already know, it is 370, right? Yes. So that's it. This is Newton forward interpolation formula. So they will give a set of table. We need to interpolate the values in between those x. Now I'm going to give formula for Newton backward interpolation formula. That is, if our unknown lies in second part of the table, you need to use Newton backward interpolation formula. Because actually everything is same. Newton backward interpolation formula is different and other steps are similar. So I'll give the formula here. Here you just in this formula, here you will use in this formula what you do is you just change you just change y naught to yn, right? So wherever you are using y naught, that is here you are using initial value x naught, y naught, del y naught, del square y naught, you just change the formula to yn, and here it will be xn. So I'll write the formula and then you will be it will give you more clarity if I write the formula first. Okay. Newton backward interpolation formula. So y is equal to x is equal to, there we will use x naught plus nh, here you will use xn plus nh, right? Y is just y of x is equal to, right? So y of x is equal to xn plus nh. It will be x naught plus nh there. It will be xn plus nh. For finding n, we will use x naught. That is, we will choose x naught to be equal to 1991, right? 1891. But in Newton backward, you should choose xn. That is, you need to choose 1931. That is the last value. Here you should use the first value x naught. This is xn. This is xn. That's it. The only difference is Here you need to choose all the first value. In backward you're going to choose all the last value. That's it, right? So it will be xn plus del yn, del square yn, del cube yn, del power 4 yn, del that's it. I'll do one more problem. Okay. So y of x is equal to xn plus nh is equal to yn. There will use y naught, it will yn plus n by 1 factorial. You will use nabla yn, right? Just a difference between forward and backward. You will use nabla, right? So there you will use delta, here you will use nabla. So nabla yn plus n into n minus 1 by 2 factorial, nabla square yn, same, right? N into n minus 1, n minus 2 by 3 factorial, nabla cube yn plus n into n minus 1, n minus 2, n minus 3 divided by 4 factorial, nabla power 4 yn, and so on, right? Now we'll do one more problem with this. So everything is same, you just have to choose the last value. That's it. Here we will use the first value. So this is del y naught, this del square y naught. If you choose the last value, this is yn, this is del yn, this is del square yn, this is del cube yn, this is del power 4 yn. That's it. So I'll do one more problem. I'll explain with one problem. Both are similar. Only thing is you should choose the last value. So problem 1. The following data are taken from a steam table. The following data are taken from steam table. So it is temperature at Celsius, and it is pressure at pressure kgf per cm square. So we don't worry about this. Just take this as x, just take this as y, and this is 140, it is 3.685, and 150. Make sure that the interval width is same, then only you can apply Newton forward and backward. So 4.854, and for 160 it is 3.602, and for 170 it is 8.076, and for 180 you use 10.225. So we need to find the pressure, at temperature 175 Celsius, 175 degrees Celsius. Now we can see 175 lies in second part of the table, right? That is, you can take this as middle. It lies in second part of the table. So we will use Newton backward interpolation formula. Now we will find the difference table. Difference table is same, right? So you just use x, y, and here instead of del y you will use nabla y. So nabla y, nabla square y, nabla cube y, nabla power 4y. So x is 140, 150, 160, 170, and 180. So x is 3.685, 4.854, 6.302, 8.076, and 10.225. So nabla y, just again subtract 4.854 minus 3.685, it is 1.169. 6.302 minus 4.844, it will be 1.448, and this will be 1.774, this is 2.149 and this is 0.279. Subtract 1.448 minus 1.169 and this is 0.326 and this is 0.375 and again subtract these two value, you will have 0.047 and it will be 0.049 and this will be 0.002, right? So since it's backward, you always choose the last value. This is xn, this is yn, this is nabla yn and this is nabla square yn, this is nabla cube yn and this is nabla power 4 yn. Since there is only one value, y0 and yn are same here, so this is nabla cube yn. That's it. You should use substitute in formula, you will get the answer. Now you will need to find n. For finding n, x is equal to xn plus nh. Okay? In forward you will have x0 plus nh, it is xn plus nh. X is the unknown we need to find. You need to find that 175. So 175 is equal to xn. Xn is the last value in n, it is 180. So for forward you will use 140, but for backward you will use 180 plus n into h is 10, right? The interval width is 10. Now you will find n here. So 175 minus 180, so it will be minus 5 is equal to 10n. This implies n is equal to minus 0.5. N is equal to minus 0.5. Just substitute in formula, you will get the answer. So y of x is equal to xn plus nh is equal to yn plus nab yn plus n by 1 factorial nabla yn plus n into n minus 1. Sorry, I actually made some big mistake. Sorry. Formula is plus here. N into n plus 1, n plus 1, n plus 2, n plus 1, n plus 2, n plus 3. Sorry, extremely sorry. So you need to formula, it is n into n plus 1. In forward you will have everything as minus. In the backward you will have n plus 1, everything is plus. So n into n plus 1 by 2 factorial nabla square yn plus n into n plus 1 n plus 2 by 3 factorial nabla cube yn plus n into n plus 1 n plus 2 n plus 3 by 4 factorial nabla power 4 yn, right? Now just substitute n to be equal to minus 0.5 and we know all the value yn, nabla square yn, nabla cube yn, nabla power 4 yn. So what is yn? Yn is 10.225 and n is minus 0.5 by 1 factorial. Nabla yn is 2.149 plus n into n plus 1, so minus 0.5 into minus 0.5 plus 1 divided by 2 factorial into nabla square yn. So it is 0.375. Just continue for this term and this term. You will get the answer as 9.1, right? So you just change the formula to plus, right? This yn is equal to n by 1 factorial nabla yn n into n plus 1. So for forward everything will be y0 and it is minus, and for backward everything will be plus, and instead of y0 we will use yn, that is we will use the last value for difference table. So that's it. This is Newton backward. So you just take one as exercise problem. So x, y, both are same. When the asked data lies in the first part, use forward. When the asked data lies in the second part, you use Newton backward. So x is 1, 2, 3, 4, 5, 6, 7, 8, 1, 8, 27, 64, 125, 216, 343 and 512. Find x find when x is equal to 7.5. Find when x is equal to 7.5, right? Again, you can see from the table itself they are given the cube roots, right? Sorry, cube of that number. 1 cube, 2 cube 8, 3 cube 27, 4 cube 64, 5 cube 125, 6 cube is 216, 7 cube is 343, 8 cube is 512, right? When you look at the table, it is like cube of that number. Now we need to find y of 7.5. You can see 7.5 lies in the end of the table, so therefore you will use Newton backward interpolation formula. Find difference table, find I'll just find n, so x is equal to xn plus nh, so x is 7.5 here, xn, the last value for x is 8 plus n into h, n is h is 1, so 7.5 minus 8, so minus 0.5 is equal to n, and make use of difference table to find yn, nabla yn, nabla square yn, and then you will use formula, you will get the answer. The answer will be 421.88, 421.88, right? So this is the answer. So that's it. So this is Newton forward and backward interpolation formula. So when the required data is in the beginning, you use forward. If it is back, you will use Newton backward interpolation formula. So next class, that is next class, we will see Lagrange's interpolation formula, and that is again we are going to find exactly the same, but the interval width will be different. Here the interval width is same, but in Lagrange's the interval width need not be same, right? The next class we will use Lagrange's interpolation formula, so that we will finish interpolation, and then we will go on to numerical differentiation and numerical integration, right? That's it. If you have any doubt, you can ask, or else we will leave the meeting.